Check that you have met Lesson 1 learning objectives. At the end of this lesson, students should be able to explain why there is a need for creative problem solving, explain what is meant by psychological inertia, understand Altschuler's key findings from the study of patents, explain the difference between an analytical tool and a classic TRIZICS solutions tool, explain how the classic TRIZICS solution tools work, understand what TRIZICS is for and what TRIZICS is not for, understand the historical issues that have impacted TRIZICS, explain why we start by applying standard structured problem solving, and to understand the TRIZICS roadmap and how it organizes TRIZICS into a structured process by identifying the problem as one of 4 problem types. Lesson 2 Learning Objectives. At the end of this lesson, students should be able to explain the 5 steps of standard structured problem solving, know when to start using TRIZICS with a reference to standard structured problem solving, know how to complete a standard structured problem solving template, understand brainstorming and fishbone analysis, know how to build a cause-effect chain for all 4 problem types, and know how to avoid the main problems encountered when creating a cause-effect chain. Lesson 3 Learning Objectives. At the end of this lesson, students should be able to explain when a functional model should be used, construct a function statement using simple functional language, name the 5 types of interaction, explain what is meant by the product and main useful function, build a functional model of the technical system in graphical and matrix formats, know how to create trimming solutions using functional models, and know how to model a technical process. Lesson 4 Learning Objectives. At the end of this lesson, students should be able to name the 3 types of contradiction, create a technical contradiction if, then, but statement for any problem situation, explain the difference between a technical contradiction and technical conflict, explain how the 40 inventive principles were created, create solutions to technical contradictions using the contradiction diagram and contradiction matrix, explain why some TRIZICS users prefer to focus on solutions to physical contradictions rather than technical contradictions, create at least one physical contradiction statement from any technical contradiction, use the template for solving physical contradictions, slide 81, use the table of specific inventive principles to solve the physical contradictions, slide 72, use the scientific effects to find alternative ways to perform a function, search scientific effects for ways to solve a physical contradiction. Lesson 5 Learning Objectives. At the end of this lesson, students should be able to explain which trend of evolution drives all other trends, state and explain what is meant by ideality, describe what Altschuler meant by statistics, kinematics, and dynamics, recognize trends in technical systems and predict their future development, and explain how to use the trends to solve a specific problem and how to use them for general improvement problem. Lesson 6 Learning Objectives. At the end of this lesson, students should be able to explain the difference between a function statement and a subfield statement, explain what is meant by a substance and a field, express a problem as a subfield interaction, explain how to state a subfield problem as a function statement and vice versa, name the subfield interaction types following the TRIZICS convention, understand subfield solution notation and explain why it is used for only some of the 76 solutions. Understand the 5 classifications of the 76 inventive standards. Explain how a subfield is also considered as a system. Apply the algorithm for applying the system of standard inventive solutions to improve an interaction or develop the system. Lesson 7 Learning Objectives. At the end of this lesson, students should be able to create ideas for how to solve a specific problem or improve a system or process using the concept of ideality. Explain the 4 main stages of the S-curve and what the y-axis represents. Know how to determine at which stage on the S-curve a system or component is at, and define a strategy for further development of the technical system. Explain what can drive the move to a new S-curve. Explain why some systems can revive. Lesson 8 Learning Objectives. At the end of this lesson, students should be able to apply the 9 windows tool to a specific Type 2 or general Type 3 problem, use 9 windows as a planning tool to identify potential future problems or contradictions, use the anti-system as a tool to prompt radical new ideas and solutions, use the DTC operator as a tool to prompt radical new ideas, explain the difference between subversion analysis tools SA1 and SA2, use SA2 to create a list of potential failure modes, use SA1 to create root cause ideas. Lesson 9 Learning Objectives. At the end of this lesson, students should be able to know which problems to use for arrays, explain why TRIZICS uses Altshuler's matrix as well as inventive standards, know how to express a technical contradiction as two technical conflicts TC1 and TC2 in terms of opposing parameters and opposing tool-action-object interactions, and use both Altshuler's matrix with the 40 principles and subfield modeling with the inventive standards to solve technical contradictions. Explain what is meant by a raw resource and a secondary resource. Explain how many IFR1s we create. Explain what is meant by IFR2. Apply the basic ARIES 85C template. Know where to reference a complete description of the original ARIES 85C. At the end of this lesson, students should be able to explain the difference between fixing root cause and fixing a symptom, explain the main reasons root cause fails to be identified and what actions to address those common issues that impede root cause determination, know the 3 main RCA rules commonly used in standard structured problem solving, know how to use the TRIZICS tools adapted for root cause determination, and know how to follow the roadmap and use the TRIZICS template for the standard structured problem solving, incorporating TRIZICS tools for root cause analysis. At the end of this lesson, students should be able to know how to use the TRIZICS roadmap and template, explain the 4 problem types and the recommended sequence for applying the appropriate analytical tools, formulate the specific problem into the model formats to be able to apply the tree solution tools, understand and use the guidelines for which classical trees tools are used, create a basic implementation plan, invent, innovate, and solve impossible technical problems systematically using TRIZICS, the theory of inventive problem solving.